Okay, so the last speaker of this afternoon is Bilson Castro Lopez from Instituto de Ciências Matemáticas de Madrid. And he will speak about hybrid spaces in Deligne-Mumford stacks induced by green functions.
Good afternoon. Can you hear me? Okay. Thank you for the introduction, and thank you to the organizers for giving me the opportunity to speak in this wonderful event. So this is a work in progress about my PhD thesis. The outline of this talk will be the following. I am going to speak firstly about some definitions, notation, and examples that help us to understand the construction of the hybrid space for complex manifolds. And also in this second part, I am going to speak about some properties about the hybrid space. And finally, I am going to speak briefly how to extend this construction to the moduli space of curves. So through this talk, X will be a complex compact manifold, the reduced simple normal crossing divisor. If the divisor can be decomposed in his irreducible components by an stratum, we mean any connected component of a non-empty intersection of irreducible components of the divisors. So to the pair SD, we can associate a polyhedral complex space, which we denote like a sigma XD. But let me explain with an example how to do this association. If we have a complex manifold and D has two irreducible components, then we have 5 strata, the total space, the 2 irreducible components, and the 2 points which results of the intersection of the 2 divisors. Okay, to every strata, I am going to associate a cone. For example, for the total space, I am going to associate a point. For every irreducible components, I am going to associate an array that can be identified with the real positive numbers. And for every point, I am going to associate a 2-dimensional cone, which is generated by the 2 rays. So in this case, our complex polyhedral space will be 2 2-dimensional cones glued along the 2 rays. Okay. Now I am going to define the green function for a Cartier divisor. Sorry, I forgot the T. If we have a continuous function defined on the complement of the support of the divisor, then a green function, that function is a green function if for every point in the manifold there is an open neighborhood and a local equation around of the point such that the locus zero of that local equation is equal to the intersection of the divisor with the open neighborhood, and minus log of z of the norm of the local equation plus g extends to a continuous function. Here we have another definition. If we have a divisor and U is a local coordinate chart, we say that that local coordinate chart is an adapter chart if the following 3 conditions holds. The first one is that if we denote by J the set of indices of the irreducible components that have non-empty intersection with the closure of U, then we ask that the intersection of U with dj, that dj is the intersection of the irreducible components with indices in J. That intersection is not empty and equal to the intersection of U with Y, where Y is a stratum of dj. The second condition is that for every irreducible component, there is a local coordinate such that the locus 0 of that local coordinate is equal to intersection of u with that irreducible component. And finally, we ask that the norm or every local equation is less than 1. So with this definition, I want to avoid this kind of open adapted charts. Sorry, because I don't, it's not pointing, sorry. Huh? Anyway, there is no problem, okay. So just a notation to every adapted chart, we are going to associate like YU, his stratum, and sigma U as the cone associated to the stratum. So stratum, sorry. So now with those two definitions, I am going to define a local equations. If we fix a collection of green functions, one of them for every irreducible component, if we consider an adapted chart, then we have two things. We have two options. The first one is that the set J that I defined above, which is the indices of the associated to the irreducible components that have non-empty intersection with the closure of U. If that set is non-empty, then we define the function Fu, where it's defined in such a way that JTH component of Fu is determined by the green function Gj. Otherwise, if J is empty, we define the zero function. So this construction of these local functions help us to speak about the existence of functions in the complement of the divisor to the complex polyhedral space, such that those functions locally looks like the local function that I defined above plus an unbounded function. So now I am going to define this set, which is x minus d times 0, 1, open in 0. This joint union with the complex polyhedral space in the 0 fiber. And over this set, I am going to define this function, who is going to be t times the function f that I defined above, if t is different to 0, and the identity if t is equal to 0. So with this function and with the set that xd, we define the hybrid topology like the quartz topology, such that the inclusion is an open immersion, the projection is continuous, and the function defined above is a continuous function. With this definition, looks like this hybrid topology depends on the choice of the function j, but we prove that the hybrid topology is independent of the choice of the green functions, which is something good. But let me explain with an example how this topology looks. For that, if we consider P1 and D is a point, then the hybrid topology can be defined by a function by the proposition above. The function is the following: minus t times log of the norm of set if the norm of set is less than 1, and t is different to 0, and 0 if the norm of set is more than 1, and t is different to 0, and the identity if set is t is 0. So what we want to calculate here is the inverse image the fiber of an inverse image of one open of the real positive number. This set is comma t such that minus t log the normal set is less than is between A and B. If we organize this, we have that the norm offset is between these two values. So what I am going to do now is compare two topologies. In the left side, we have the product topology. We can see that these values converge to 0 as t goes to 0. But in the right side, we have the hybrid topology. Note that the 0 is on the top because we have a minus over there. So if you can see, if you can compare the two pictures, you can see that the right side looks like an exponential blow up. So as an application is that if we consider toroidal divisors, which is a formal sum of irreducible components of the divisor D, is a toroidal divisor supported on D with coefficients in the real numbers, then it's well known that we can associate a piecewise linear function such that if we have a rate tau, and if we suppose that the rate tau is generated by a primitive vector, then the image of that primitive vector is equal to minus the order of the toroidal divisor along to the irreducible component associated to the ray. Yeah, and with this, we have a piecewise linear function. Otherwise, also, if we consider a green function associated to the toroidal divisors, we can construct a function g on the hybrid topology, from the hybrid topology to the real numbers, such that it's going to be t times the green function if t is different to 0, and the piecewise linear function if t is equal to 0. And the claim is that this function is a continuous function in the hybrid topology. So you can see every piecewise linear function as a degeneration of green functions in this case. Now, what I am going to do is speak briefly about how to extend this to the moduli space of stable curves. Just only saying which one is the polyhedral complex space. For that, if X is a complex smooth variety and D a simple normal crossing divisors, 2 here show that the polyhedral complex space can be identified canonically with a dense open subset of the skeleton of the pair XU. So later, Abramovich, Caporaso, and Payne defined the skeleton for toroidal Deligne-Mumford stacks. In particular, they proved that the skeleton associated to MGM bar MGM is precisely the tropicalization of the space of the moduli space of tropical curves. Is the space of tropical curves. Sorry. So this will be our candidate for the polyhedral complex space. Because with this, we can take the analytifications of the quartz moduli space associated quartz moduli space of stable curves, which goes to the tropical moduli of stable curves. So these kind of functions, like f, can be constructed using certain kind of manifolds, which are which are in the analytic topology are local étal presentations to the. Sorry, I am a little bit confused. If this is the analytic stack, so what we are considering here is an analytic presentation, étal analytic presentation. This is a complex manifold, and we construct all this machinery in this part, and this construction induce a construction between the analytification of the quartz moduli space to the space of tropical curves. So, and with that, we consider the hybrid space for the stable curves, like before, just for this setting. And one of the reasons of considering this is because certain theories of string theory can be calculated in the part of the can be calculated in the part of the quartz moduli space of stable curves, and some theories in quantum field theory can be calculated in the tropical part. So the idea with this space is to see some theories of quantum field theories as a degeneration of some theories of string theories. So that's the motivation of study this space. So thank you.